Hello. Good morning, good afternoon, good evening, good night, wherever you are. We're back to another Stories of Facilitating Software Architecture and Design. With me, my co-conspirator, Andrea McNorsky. And today we have Liz Fong-Jones. And I'm very curious about your story today. Welcome.
Thank you for having me on. So this story is a Google S3 war story. So it was July 2018, and I had just joined the Google-wide incident management program as one of the volunteers. And my pager started going off because a bunch of Google Cloud was down. People couldn't connect to Google Cloud backends. They were just seeing timeouts or error messages, and people were not having a great time. So I hopped on to the incident bridge and became the incident commander for this incident. So many companies have these kind of centralized incident management groups that kind of handle overarching response to very broad outages. And Google is no exception to that. At any time, there are probably, I think, 30 or 40 people scattered all around the world who are available at a moment's notice to jump in case there's some kind of widespread incident that no single team at Google can solve. And one other useful thing to know here is that I had previously worked on the piece of software that was implicated in this. That I previously had worked on the Google front end, which is basically the giant reverse proxy that handles requests for Google.com, docs at Google.com, basically anything at Google.com. It flows through the Google front end. So, was on this tragic day, there was an alert went off that basically said, almost every single Google Cloud service is down. That we're not answering requests for cloud.google.com. It didn't just affect Google services; it affected services of every single customer that was using Google Cloud as well. And the set of teams that was initially brought in, right, like was obviously the team responsible for the Google front end, right, like both the development team for it as well as the traffic team, the set of people who handle the kind of load balancing and routing and kind of all these front end pieces that are required to get your request from point A to point B. But when they realized that it was, not just their own services, not just Google Web Search, but that it was Google Cloud's customers, that there were dozens of services impacted, they signaled a Google-wide escalation, and that's where I got brought in. So that was the first incident that I worked as part of the Central Incident Management team. It's a volunteer position, I should add, and it's not a full-time position. You have other responsibilities too. And this outage lasted about 30 minutes. And a lot of what we were doing was not necessarily hands and keyboard fixing, but just communicating, keeping people in the loop as to what was going on, communicating with executives, communicating with stakeholders, communicating with Google Cloud reps who were having to explain to their customers what was going on, as well as, doing some air cover for the impacted team. And what I think is really interesting about this incident that I wanted to highlight here is that this incident was not resolved by the set of people in the war room or on the escalation call finding the solution together and like deploying the fix. The fix to this evolved in parallel with the escalation room. And it didn't take people in the escalation room fixing it. Instead, we had someone raise their hand and call into the escalation room who we would not have thought to tag in. And they said, I think this was my change that did this. And I've already started rolling it back, right? And I think this is a really, really classic example of two things, right? Like it's an example of distributed debugging where everyone potentially holds the answer to it in their head, right? Like that you cannot kind of force centralization of your incident band. And secondly, it's a really, really important lesson about psychological safety, right? This was not an environment where the engineer might have hidden under the desk or tried to cover up evidence of the change that they pushed because they were afraid of being fired, right? Like they wrote in, right? Like they called into the bridge and said, hey, like, this was my fault, right? We don't love the word fault, right? Like, we try to be, blame aware. We try to emphasize that, the fact that you as an individual can make a mistake indicates that there's some kind of systematic flaw in the system. But regardless, right, like, this person felt safe enough to raise their hand to self-correct the error and also to tell everyone else about it so that we could stop looking around for the root cause, right? And there's heaps of details as to, how exactly it happened, and the best I can probably do for you there is to point you to the public Google retrospective, which goes into some degree of depth about it. But I think, from a engineering leadership perspective, right, like the details of how this incident manifested don't matter quite as much as kind of the people lessons about how you structure resilience and how you structure incident response. So I imagine that might raise some questions for you, Andrea and Kenny. What would you like to dive into?
Let Andrea go first.
Oh, okay.
I know she has tons of questions.
This is awesome because I love it that kind of hearing the story of it happening, and you talked about two things. First, you talked about this critic debugging and the psychological safety needed for this person to step up and say, "Hey, I think I know what's going on. I'm running it back." But one of the first questions is like, how did you validate? Because I mean, until this person goes and undoes something, which could be just revert last PR literally and deployed. But in the meantime, it could be that that's not the cause. It could be one contributing cause, or they could have been wrong basically. What happened in the confusion stage would be my question from a fact point of view, and I have a follow-up question.
I think the symptom that people observed was that they were either, getting timeouts, or that they were getting responses saying that, none of the front ends or back ends were healthy. And it took us you're right, it took us some time to recover from this, right? Like you don't go from 100% down to 100% up immediately when you deploy a fix. But the thing that I think we were able to validate was some leading indicators, right? So this particular bug was a bug that resulted in the Google front ends that were serving requests for Google Cloud resources. Those were crashing when they encountered this unexpected input. So when the developer deployed the fix that resulted in those front ends no longer receiving the invalid input, the crashing stopped immediately, right? We had other problems, like not enough backends available to serve, right? Like Fender inferred too much pressure on the backends that were up. But like over time, we could start to see the number of available front ends stabilizing, right? Like, and that was kind of the sign that we were on the right track. But yeah, I think the other thing here was that, obviously it's a lot better to have some kind of idea of mechanism of causation, right? Like if something fixes itself and you have no idea why, right? Like you have no idea whether or not it's going to come back, right? But you have an explanation of, this bad data tickled this other bug, right? Like then that's something you can actually validate. That's actually something that you can check.
Yeah.
Also, I think the other thing here, right, like is if you just default to reverting whatever happened, that put the system into an unstable state, most of the time you will be correct. You will be able to return things to a stable state. That's not always 100% true, but it's definitely a good default first thing to try, right? Like we talk a lot about the idea of instead of trying to fix forward, right, just roll back, right? Like you have a known working state that you can hopefully get back to, and that should ideally be the happy path for trying to resolve things.
Yeah, totally. I did wonder how did you conceptualize all of that? The other kind of questions that I have, one is on the people side, and the other one is on the design changes that might happen, and they're kind of interrelated. For example, for one change to trigger so much failure, that kind of talks about like, is the define actually quite right? So I kind of wonder how the people side of this define change because of the incident trickle down. I'm very curious about that. Like how was the kind of orchestration of the design changes happen really after the incident? Because I'm sure it wasn't 10 minutes later we changed everything.
This was really, really ironic, I think, right? That a system that we had put in place to limit the blast radius of changes paradoxically caused a system-wide outage, right? So here's a little bit more technical detail to kind of unpack that, right? Every functioning software organization has some kind of canary deployment system, right? Like you have some mechanism of rolling out software to, 1% of 1% or even 0.1%. I think this was even supposed to be a 0.01% traffic experiment. So having worked on this team before, right? Like, I had the requisite context to keep in my head when this person came onto the bridge, right? Like, because I knew that there was a development cluster, right? The people who developed the Google front end have the ability to push their own binaries, right? Like to a subset of the cluster that serves a very, very, very small subset of the traffic, right? 0.0001% of the traffic, right? But the challenge here was that even though they had meant to only serve, this small fraction of the traffic, right? Like the assumption was if something goes wrong with that, right? Like you've only failed a vanishingly small percentage of traffic. What was not accounted for was the fact that any host that appears in the list of available backends, even if it's set to receive less than 0.1% of the traffic, you still have to have information about it in the list of available backends to send the traffic to, right? That if you are intending on running a canary experiment, you have to give information about which host is the canary and what percentage of traffic to route to that canary. And that information has to be pushed out globally. And that's basically where the problem was, right? Like, so a safety feature to test a release before it went into production, even the server itself didn't have any bugs. But the way that it communicated information about, hi, I'm available to serve, that's what caused every single host in the fleet that was talking to it to try to get information on, hey, what protocols do you support? Just on the off chance I need to route traffic to you. That's the thing that caused the system-wide outage.
Right. And how was there a design change because of it? Because,
So I think there have been periodic efforts at Google and Amazon and, pretty much every single large hyperscaler to think about how do you test and validate global changes and recognize that global changes are very, very dangerous. I think the thing that was missed here, though, was that the list of backends for a important service like this was, in fact, a globally distributed set. So I think basically, right, like, yes, in general when you're working with a global system to proceed more carefully, to, right, like have automatic rollback, right, like to detect crashes. But if you're not aware that you should be looking for that, right, then I think it's a lot harder to test that. I think the other factor is, right, like, backwards compatibility, right? Like I think that if you test things to make sure that things are forward and backwards compatible, then you're going to have a lot better of a time than if you are rolling out software in a way where you can send an input that something else or send an output that something else rejects as an input. So that kind of goes to the old Unix philosophy of be liberal in what you accept, be conservative in what you output.
What I liked what you said is if you want to really create resilience, you also need to create resilience in humans, right?
Yep, exactly.
I think that's, I really like that quote. Never thought about it in that way. So what I guess you created there was psychological safety for that person to jump on the call. So I have questions. If you look at the system, so how did management or leadership reacted to that person calling in first, and of course saying, "Hey, it was my fault." What can you remember? What was the reaction at that point? Because I think there's very much to learn for other organizations there.
I think that the number one thing that executives at Google tried to do, right, like, is to stay out of the way, right? Like they don't want to pressure the team. But they, at the same time, have a responsibility to make sure that an outage is being addressed with sufficient urgency, that it's being given the resources that it needs, right? So when you have, executives joining the bridge, right, like, they're not going to personally speak up and, like, intimidate the person even from having said, hey, like, I recognize that and thank you. Right? The thank yous happen afterwards, right? Like, even when the person came onto the bridge, right, like, I as an incident commander was not, like, immediately, like, worried about this person's feelings. I was just like, thank you for that information. Now let's see whether we can validate whether your fix worked, right? Like, what time did you say you landed that fix, right? Like, where can I see it rolling out, right? Like, there's so much in motion at the same time.
Yeah, so at the time you're focusing on fixing the problem. So you say thank you, of course, every information, every transparency is, of course, helping you create that goal in the moment. And afterwards, what is done afterwards to make sure that, if there's still repercussions afterwards, then it will
Exactly,
not
right?
help
Like,
people to speak up in the moment.
Thorough retrospective processes, right? Like making sure we're learning from it, making sure that they know that it wasn't their fault, right? Like that, there are systematic changes that we need to make across the system. And then, just making sure that we're all debriefing and talking about it. And so I think, right, like there are, thing, right? Like we're having this conversation today. But you can imagine in the weeks after this incident, right? Like every Google S3 team had like at least one representative like join one of these kind of learning sessions, right? Like where we talk about major outages, major incidents, right? And this outage was one of many incidents that we discussed in these ops reviews, right? Like we don't only talk about the high profile incidents, right? Like we talk about individual learnings that you can have from any team, right? Just because this incident was high profile did not mean that it was, like and usually worthy of being of like learnings. Every incident you can learn something from, right? Like, and I think that's important to emphasize is that you have to have a culture of continuous improvement, and you cannot just do this for the large incidents. You have to do it in the smaller incidents too.
Yeah, that's great. Yeah, I remember one time at a small company where a developer made a mistake and it cost the company like 10,000s of euros, which was a big deal for that company. And I remember
You can joke about like, that incident cost you $10,000. Why would you fire the employee that now has $10,000 worth of learning?
Yeah, we didn't. So I talked to the manager because I was a tech lead. I said, the manager was fine. He was like, oh, it happens. And I said, can you please call the developer because the person is in stress. It reminded me of your
recognition, right? Like you can give people a bonus, right? Like, right? Like people may be like, why would you give a bonus to someone who screwed up? But the answer is they didn't screw up, right? Like,
no,
the system let them down, and they had the best possible reaction to that was to immediately roll back and also to call in.
But yeah, and what reminded me of your people also need to be resilient, and that's what I saw happening. The moment the manager called that dev, it's fine. No, you did great, and everyone failed. Everyone together made sure. I can't remember the exact thing, but it was very heartwarming, right? And you saw that person, like, if I think about resiliency, you saw that person moving back to the original state and be more resilient. So that's, I like that metaphor of humans also need to be resilient. So.
And have you ever been in a situation that is kind of also an incident, but what you think should have happened didn't happen? As in, like the opposite thing. Have you experienced the opposite of that?
Thankfully, I've been on teams that have kind of psychological safety. I think the thing that I do see happening more often is not necessarily in the heat of the moment of the incident, but often it's challenging to get investment in reliability before there is the catalyst of an incident, right? I would much rather not have the incident, right? Like I think that it is potentially a problem, right? Like when you have, all of the praise and awards to the people who do the firefighting and not the people who prevent the fire from even breaking out in the first place, right? And I think that I've seen organizations struggle with technical debt. I've seen organizations prioritize the short-term over the long-term, right? Like, and the thing that I have to keep in mind is that it's very, very difficult to expose safety as a signal aside from, right, like outages, right? Like, we talk about the triad of cost, surface area, and safety, right? You can right, you can drag the around anywhere in that kind of tri-point space. But if you stress safety too much, it'll suddenly snap. You don't really have an indication there.
It reminds me also a little bit about this person showing this Superman clip where first Clark Kent goes to this little boy standing at one of the waterfalls and say, hey, watch out, don't fall down. And nobody believes Clark Kent. And then all of a sudden the boy drops, Superman comes in, saves the kid, and then everyone's praising Superman, right? While Clark Kent could have be careful, not make that incident. So how would you know you're in a psychological safe environment? What are the key signs you look for or see, or red flags even? So how would you, what are some heuristics you have?
That has a lot to do with how do we talk about smaller failures before there are bigger failures, right? Like how do we make sure that we have a culture of continuous learning? Are people punished for speaking out, right? Like, even on things like, hey, like, I might slip this deadline, right? Or hey, we're really behind on story points, right? Like I think that's kind of the primary smaller steps that you take, right? Like in order to then have the psychological safety in case something major happens. I think making sure that we're listening to feedback, especially, right, like, in this category of, right, like there's no such thing as a dumb question, right? Like I think that it's important for people, especially newcomers to the team, but like I as a senior even try to model this, right? Like that it's okay to ask questions that might seem obvious to someone who knows the answer, because that way, right, like we emphasize that we all have things to learn, right? Like that there's kind of no perfect expertise.
Yeah. It reminds me of starting Aikido, going with a black belt and saying to the person having a black belt, "Oh, sorry, you need to train with me." And then the black belt said to me, "No, not at all, because I can learn so much from you." And this is, I think, what you're saying, right? There's always learnings in people, and I think that's one thing to notice for them.
Yeah, I really like those three things that you said. It's like your heuristics for the psychological safety. It's like, can we talk about smaller things? Can people talk about problems? And if people feel like they can't ask dumb questions, that kind of fear and silence, when you're in a call and people go like, and they're like, how to kind of,
It says it for them you don't know, and like no one on the call knows, and everyone stays quiet, right? Like that's potentially a problem.
yeah, yeah.
Do you also
Yeah.
look for like juniors talking less than seniors, right? Is that something?
Yeah, definitely. Making sure that everyone has an opportunity to give their opinion, give their input, right? Like ask why we did something. Maybe that's a sign that we're missing documentation.
Absolutely. Yeah, and how do you feel about collaborative design techniques? Like what are your default collaborative practices, basically?
Yeah, I think that when we are designing things, it's important that teams own software products, and therefore that teams own designs, not individual, right? Because, that individual may transfer teams, they may leave the company, right? Like, so I think it's important that the people who are going to be accountable for running the system in the long term have input into it, feel ownership of it, right? And yes, you can have a lead author of a design, right? Like, but I think that the broader team that surrounds it needs to be in the loop, needs to have an understanding of the system, needs to understand why the decision was made, right? Like, and I think kind of combining those two things, design and psychological safety, right? Like, the ability to ask, why did we make the decision, right? Like, what are the conditions under which it might be okay to revisit it? Rather than, oh, that decision was made 10 years ago. I don't know why. I don't feel comfortable with changing it, right? Like, it's happened so long ago that we've forgotten it, and who knows, you might blow it up by changing that, right? So there's kind of this concept of like a haunted graveyard, right? Like no one dares, step foot in a haunted graveyard because there's just, spooky stories of the last person who did that disappeared. No one can remember anyone ever walking in the haunted graveyard, right? I think that when we treat design as kind of a living conversation, right? When we are looking at production, right? Like when we're looking at things to have an understanding, not just of what was the system as designed, but also what's the system as built? How's it behaving, right? I think that's true regardless of whether, you are designing with an AI teammate, a human teammate, right? Like I think either way, right? Like it's this group of people who support the software.
Yeah, they build the theory, like Peter Knoll said. Right? Oh, that's very, like, I like that design as a living conversation very much.
Thank you. I think this was it, our bite-sized story. So thank you for joining us, Liz. Thank you for telling your story. I think a lot of people can relate to it and hopefully get some learnings out of it themselves. So if you're listening to this, watching this, reading this, please like, subscribe, so more people can get in these conversations, and hope to see you next time. Bye-bye.